Let's simulate a live session. So
let's simulate the live session. Yes.
yeah.
Oh, that's no problem.
Okay. Yeah.
Or let's just simulate a conversation between two people. That's also good.
Yeah. Hello, guys. I'm back. My name is Jeferson Costa. I'm a chemical process engineer with expertise in plant design. And today I am with the...
But who are you?
Mathieu Westerweele. Sometimes there are some names that is difficult for me to pronounce. Okay,
It's a really Dutch name indeed. Yes, yes.
How
Westerweele.
Westerweele. Okay.
Yeah, that's close. That's good.
I am with Mathieu Westerweele to talk about process modeling, process simulation. Thanks a lot, Mathieu, for accepting my invitation. We know that you have a busy time, you are an entrepreneur, you work a lot with process modeling, but you accept my invitation. Thanks a lot. And not because of the process modeling.
It's weekend.
Yes. And you were very nice also to reply for one of my posts that I talk about colors blind. As people know, I am not colors blind, but you did a comment, and that encouraged me to talk to you to accept my invitation. So thanks a lot.
Yes, that's good. No problem. Let's have a nice discussion. I prepared some slides on color blindness as well, actually. Maybe that's nice to share with you guys. I had one of my colleagues, well, you know these circles that you can see numbers in it? But I will show in a second. That's nice. Okay. Or we can start with that, whatever.
I will let you...
We're talking about it now. Should I share my screen?
Yeah, you are able to share. But just before you start with your presentation, let us know a little bit about your career. I have seen you dedicate your career to process modeling, and you were a researcher also. But you decided, there was a time that you decided to be an entrepreneur. Could you link this from the university to the entrepreneurship? How it was for you?
Oh yeah, that's fine. Well, I started my studies, chemical engineering, back in 1991. And after that, I didn't feel quite ready yet to go into the industry. So I decided to do a PhD study. And that was on dynamic modeling, so equation-based modeling. And actually on how to get from a process to a model of that process. Because that's sometimes quite tricky, and there was quite some methodology behind it, but it's not always clear. So we searched for some algorithms during the PhD, and also during the PhD I made a first version of the tool which is now called MOBATEC Modeler. So there is quite some methodology behind it, how to get from your process to the model of your process. But I want to give a short demonstration later on in this discussion. And then at the end of my studies, I found a job actually with a company that was making operator training simulators. But they were used to typing out all the code they needed. So huge listings of coding, and also quite error prone and a lot of debugging required. And I generated a tool which could generate actually the equation that you needed. Well, we tried that, and I adapted the tool such that it could generate code for their solver. And that was, that worked very nicely. But after 2 years of working there, I found actually that the tool could do more, that it was not only for operator training simulators, but you could do so much more with that. And well, I got in a little dispute with the company owners, and after some while I decided to do it on my own. Actually, in the time that I worked there, I met somebody, my colleague Jan Laurens, and in his time he wrote his own equation-based solver. But he also, well, he was also used to typing out all the code and then solve it with his solver. And I have written a piece of software that generates the equation but doesn't solve them. So I thought, well, if we put 1 and 1 together, 1 and 1 is 3 in this case. So we started our own company with the two of us, which was a lot of fun. I think we did it with just the two of us for 7 years. And in the meantime, I was actually the coordinator of a program which is called Process and Product Design at the Eindhoven University of Technology. This is a special program where students who have finished their master, they want to do an extra study to bridge the gap between theory and practice. Because you learn a lot of theory in university, but how to apply it in practice, that's quite something else. So this is a special study in which all the lecturers are actually from industry, and they give classes 1 time a year, and they give real casework to the students. So they really learn to bridge the gap. And while I still give classes there actually every year, I've been doing that for 15 years now. But I quit being the coordinator because at one point in time, MOBATEC started to lift off, and I couldn't combine that anymore. So yeah, but in the first 7 years I did that. That's also because if you have a small company with just 2 people, then your income comes a bit like this. Mm-hmm. And that's, well, you need a bit of steady income. So if you do 50% of your time something else, that works a bit better. But then I think in 2012, we started to getting more and more questions if we could do larger projects. So I needed to grow the company. And well, it turned out to be great that I worked for PPD because there were a lot of students there. So the first employees of MOBATEC actually came from that study. Mm-hmm. Because it's, well, I met these guys and I worked with them for 2 years. So I know the people who really liked modeling and they could join. And then it also turned out they were from all over Europe. So not only the Netherlands. And well, typically they wanted to go back to their country because they preferred living there. So I said, no problem, as long as we can communicate online, then that's fine. So at one point in time, I had somebody in Spain, 3 people, I think, in Belgrade in Serbia, someone in Romania, someone in Sweden, a few people in the Netherlands. So it was, well, we didn't need COVID to do this kind of working. So we've been working like this already for, I think, close to 10 years. And I like it a lot, actually, because I'm just in my home. And actually, it gives a lot of freedom also to my employees, because, well, I let them do their work, and I don't mind when they do it. It's not a 9-to-5 job. We have a project, it takes a certain amount of time, and I expect the project to be finished, but how you get there, well, who cares? It's about the end product in the end. So if you want to go jogging during the middle of the day or visit your grandma or whatever, well, feel free to do so. And that gives a lot of freedom. And that's how we work at MOBATEC. And I think once or twice a year, we all come together and have a nice meeting with a drink and a dinner and some fun. And for the rest, we communicate like this. That's how we do it. So that's how I became an entrepreneur and how I'm enjoying it very much. It's a bit depending on the number of projects, by the way, how many people we are. So it's a bit balancing between, well, say, 6, 7 and 13, 14 people, something between that, depending on the amount of projects that we do at the moment. So it's not a big company, but I like the dynamics a lot of it. And well, I enjoy working like this. It's been a dynamic ride so far, with ups and downs, obviously, but so far so good.
Very, very nice and interesting. And I have heard about MOBATEC maybe 1 or 2 years ago. Mm-hmm. You have, and it was on LinkedIn. Did you decide to have some kind of marketing specific for LinkedIn, or it was just a coincidence? You start sharing something there?
No, it was actually due to all the COVID things going on in the world. That was in 2020, near March, April, something like that. And everything was going slowly in lockdowns, etc. So we thought, wow, we need to do something. And we decided to do some free webinars. And well, then we needed to post stuff on LinkedIn. So we started to become a bit active on LinkedIn for that. I'm not really active on LinkedIn. We have quite enough work to do already. So, but I check LinkedIn once in a while. Sometimes I post something and that works fine. And sometimes I get some very nice comments or contacts from LinkedIn. But yeah, I could probably get a lot more out of it and even grow or whatever. But I like the dynamics as the company is right now, so that's just fine. And I did do a LinkedIn marketing thingy a few months back, and that. Yeah, I noticed then you have to pump in quite some money, but it gives me almost the same results as when I post something myself online, since I have built up rather a community. So if I post something, I always notice that it's read by, I don't know, 8,000, 7,000 people, and that's fun. That's fine. That's fine.
It's not about expending money. There are a lot of strategy there for sure. And
yeah, there is.
Talking about the colors blind, you did a presentation, so you can share that if you want to.
Yeah, I was triggered. I think that's a few months back. You asked some questions about color blindness, and I saw that, and I thought, well, let's reply because I was diagnosed with color blindness, and.
It was very interesting because I received a question from what was my point of view about colors blind getting a job as chemical process engineer. And it was not only one person, was more than one person asked me in the same week. So I decided to share something to see if someone could help with that.
Yeah, well, I did this test, I think, when I was 12 or something. Maybe you recall it. You can see my screen?
Yes.
Okay. So what you see are all kind of small circles, and in it there are some numbers. But the thing is, I only can read one of them, and that's this one. If I don't know if you can see my mouse as well.
Yes.
But I see here a 12. And then for me, these are just circles with small circles in them. But most people who are not colorblind can actually see numbers there.
Okay, I can see, but only instead for me that is not colorblind, it's tough to see. 242.
It's rather tough. It's rather tough, I recall. But there are some numbers. There's a 6 something and a 71 or so, apparently. But then I edited, or a colleague of mine edited the circles, and for me these circles look exactly the same. But apparently now you can see no numbers anymore, and you see what I see.
Yeah, the 12 is very, very visible.
Yeah, the 12 is still visible, but the 12 is only there to prove the point that the circles are working. That's why I could see the first one, the 12. Because it's really contrast. But the thing is that I cannot make the difference between shades in colors. So it's not really color blind, because I always get this, oh, you're color blind, and what color is this? And then, wow, this is bright yellow, bright blue, bright green. And so I thought, come on, this is colorblind doesn't mean I'm blind. It means I cannot see the shades of colors. And where it's apparent is in something like this. Sometimes there's a presentation going on, typically on a bad beamer. And then the guy says, well, the red line, blah, 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 is this. And I'm there. Which one is the red line? I have no clue. They use thin lines. And for me, the same intensity of color. So for me, it looks like this. Okay. I didn't see it change. For me, I didn't even notice I changed the page, but you probably did. So what would help for people who are colorblind is if you at least use thicker lines. But what would even help more is use different color intensities, because now I can see a blue line, a black line, a red line, and a green line. And even better would be, of course, to this.
Okay.
Then you can make your point, and then I can follow the red line. That's the only thing where it runs into problems with me, but it's not so often actually. So for the most, I can still see green and red and brown, etc. It's only sometimes when you play snooker, you know, the billiard game.
Uh-huh.
Then the color difference between red and brown for me is really really bad. So sometimes I knock in the wrong ball. So, but there are.
How it impacted to your studies and in your career?
No, hardly, because my study is not about colors, and I didn't do any chromatography studies or something. I focused on process engineering, most of which is rather black and white, so to say. So it didn't impact that much. And when things with colors were concerned, then I typically asked somebody else. Also, because, well, people talk about, I don't know, navy green or whatever, all these additions, they make no sense to me. It's green or not.
I received some questions if it's possible to be a chemical process engineer having colors blind. And you mentioned that you did training for operators. Did you notice that's something that should be important to a not colors blind person when you did the training? How was it?
No, typically these consoles of operator trainers, they take care of that already. I think people thought about these things, and the colors are there are real differences in colors. So I don't see any issues there actually, because I didn't do the training myself. What we do, I will tell you in a minute. We make operator training simulators, so we make the models, and then we connect it to the screens that have been built already. We do nothing about that. So, and typically, I also let my colleagues, by the way, build these screens, because when I make the coloring, then they say, "What did you do?" So I will stay away from that.
And talking about the subject of this live session, to start with, there is any difference between process modeling and process simulation?
Yes, there's a huge difference between modeling and simulation. But maybe it's nice if because I made some slide presentation, and then I browse through what we do with MOBATEC, and we also cross this topic.
Okay, perfect.
And I can address it. For me, well, modeling is making models yourself, and simulation is actually doing simulation with oftentimes models that somebody else built. So if you look at tools like AspenTech, HYSYS, Unisim, it's not really modeling, because you're not modeling. You are dragging some unit operations from a library that somebody else made for you, and you can fill in some parameters. That's what you're doing, but you're simulating with models of somebody else. In most cases, you have no clue what's behind it and what's actually being solved. If you want to do modeling, then you know what's being solved, and you can look inside and you can change stuff. But well, let me share my screen again. MOBATEC. So we started 16 years ago, 16 and a half years. We celebrated the 16 and a half years birthday, because 15 was during COVID. So that was too bad. So we had to postpone it for 1.5 years. So MOBATEC, it stands for Model-Based Technology, MOBATEC. Actually, we talked about this when we started. So that's the brief history. We covered that. And what we mainly do at MOBATEC is, well, we construct process models for companies, mainly because these companies, the engineers, they either don't have the time or they don't have the knowledge. or a combination of the two, of course. And we also produced our modeling software, MOBATEC Modeler, which we license nowadays, so that people can either build their own models or use the models that we've built for them. And these are some of the customers we are working for. I'm sure you will know some of them.
Mm-hmm.
But well, it doesn't matter. So, but modeling can be used for a lot of purposes, of course. And you can use it for engineering, for research, for design, for optimization, trainings, support, and a lot of more things you can think of. And in the beginning, we were actually focusing on this engineering and research, because as I told you, we were only with 2 people. So we worked a lot for a company called SABIC and DSM, which were very close by. At the moment when we started, I actually lived quite close. It was 4 kilometers, so I could ride on my bike to the company, which was which was great, and we could do some stuff there. And we did typically a research modeling. So you took one unit operation and you really zoomed into that, and you wanted to know all about it and expand your knowledge and improve the processes and debug stuff. And obviously you can also use it to optimize, so to reduce the downtime or to make more product or reduce cost, etc. Well, these are typical things, engineers know that. So, but well, before we started, you asked me to give two examples. So I thought let's include a few which we did over the years. So this one is nice. It's actually, these are examples for dynamic modeling, because at MOBATEC we focus really on dynamics, so where the time is also very important. So steady state simulators, there are a lot of them, and they started in the 1980s, and well, you have Aspen HYSYS, which are combined nowadays, Pro2, Unisim, I don't know, there are a lot of those. DWSim is a nice freeware one nowadays. I talk to this Daniel once in a while.
Daniel is a Brazilian guy, very proud.
He's the Brazilian guy, but he hasn't been on your talk show yet, or has he?
Not yet.
Not yet. He's the next one. But he's actually doing still a full-time job, so he does that all in his spare time. It's impressive what the guy did.
Quite impressive, for sure.
It's very impressive, yeah. But I think he focuses mainly on steady state modeling, but he does some dynamics at the moment as well. But well, that's nice. And I made my living out of it actually, which is also nice. So, but this was one of the examples. I think it was already 7 or 8 years ago that we did this project. So there was a company who had several processes in their plant, and one of the processes, this part, it generated heat, and it was, I think, about 24 megawatts, something like that. And these were big heat exchangers, and they exchange heat with the canal, so they dumped the energy in the canal, so to say. And then they had another part which required a lot of heat, and then they had a generator which actually generated that heat. And at one point in time there was a smart engineer who said, maybe we can heat integrate these two parts. The problem was that the parts were 800 meters from each other away. So that was quite something, and they had to think of a way how to do that. So they invested in a huge pipeline which was between those parts. Well, steady state, that all works out very nicely, but dynamically, when one part is tripping or failing or one part is starting up, you have to see how it goes. So you have to tune your controllers very carefully, and it takes quite a while before the heat from this side is here, and if there are changes, it also takes quite a while before it's from here to there because of the distance. So that's why they let us build a dynamic process model in which we could turn off and on all kinds of parts of the model and see how everything reacted and make the best controller tuning for them. So that turned out to be a very nice job, and they actually had a lot on our dynamic model, so they could calculate a lot of scenarios which they preferably would not enter in the real world. But well, with dynamic modeling, that's cheap. You just let your computer run and do the work. So that was one nice example. This was another one. It's maybe a bit similar. but this was another company, and they have several plants actually, and they use steam, and they actually bought their steam, high pressure steam, 75 bar G steam, I think, from another company. But this other company generated steam, and it was 2 kilometers down the road. So there were huge pipelines with 70 bar G steam. But at some point they thought, let's invest in our own steam boilers, but we put them on premise. The downside of that is that the distances are becoming a lot less. So if something goes wrong, then the pressure in your steam headers will drop way faster. So once again, steady state, everything is fine, but there are dynamic transition periods, and maybe during the transition your pressure drops so much that the part of the of one plant will trip, and because that part trips, another part will trip, and then you get this whole series of things going wrong. And they wanted to be sure that something like that would not happen. So we built a big model for them with all the steam headers. So this is the main picture. Actually, you could zoom in to the user plants, and there you could see all the equipment that use steam, and you could turn off and on all of them. And we did several tests, and at one point there could be a situation where the 20 bar steam header was blowing off steam, so relieving it to the air, and the 12 bar steam header was actually dropping in pressure. So that was an unwanted situation, and we had to search for a solution and what was the problem. The problem in the end turned out that to be this valve was sized too small. So it was physically, the valve was too small, and it couldn't handle the flow rate from here to here. So that was actually a nice find, because when they built the headers, and it was a turnaround, the plant had to stop anyhow, and they also invested a little in putting a new valve here. And actually that saved them in the end a lot of money. Eh? So then we see that the dynamic simulator was quite useful, because when it was relieving here and dropping here, it was only a short time, maybe a few minutes, but it was enough to trip stuff in the plants. So they saved something there. Eh? Well, these are nice examples for uses of dynamic simulators.
Let me do some questions there.
Yes.
First, how much time, or the average time, is needed to do this kind of work that you do to your clients? Of course, that depends on the big, but talking about the examples, how it's weeks, it's months?
Yes. No, these models are in the order of weeks. Before you have the first results. These are not so big models, actually, for us. So it turns out to be a few months in the end, because, well, you're running and you're doing all the examples, and you're debugging a little bit and improving your model. So in the end, it takes a few months, but to get the first results is more the order of magnitude of weeks. Okay. For this kind of models.
So in a few weeks, the management has a better idea if it's worth or not to do an investment, right?
Yes. It's actually not a big investment, especially not if you see what the gain was in the end. Because
yes. And
but you still have to convince management, because it's still an investment, of course.
And about the accuracy once the solution was implemented, it's 2%, 1% of accuracy, or deviation. How is it? How it looks like? It
depends a bit on the goal of your model and how quick you build the model. For our training simulator models, we are very accurate, and we can make up to 99% of the plant results we can mimic. Also dynamic results, so not only steady state. Steady state is easy, you can mimic it for 100%, you just tune some parameters, but it's about the dynamics. These are important. That takes a bit of more time. Actually, in the end, for this model, we found a mistake we made, because these pipelines, they have an inner and an outer diameter. And since it's 75 bar G, there's quite a difference. And it turned out we took the wrong one. And then your volumes are quite a bit different because the length is also incredible. But well, these things you find out later. But still, it was a good solution.
And usually you do that for green fields, or it's a better application for a brown field when we need to do some
typically most of our projects are actually brownfield. What we are doing. That's I don't know why, but that's the business line I rolled into, I guess. But most work is brownfield, which is actually nice because then you already have data and you can tune your model very accurately depending on the data you have. It's a good bridge to our to our next part, because about 10 years ago we started doing more and more training simulators, because especially in the Netherlands most of the plants that are here are built 50 years ago, and in the beginning there were lots of disturbances, and there was actually a very low degree of automation, so there was not much automation going on. And as a result, the operators, they had a lot of hands-on experience, so they had to start and stop all the time, and you know how their plant reacted. But then, well, smart people started doing smart stuff, and you get a lot of smart operations and a lot of less disturbances because there is a high degree of automation. It's not only process control, but very often also advanced process control. These are controllers controlling the controllers. So in the end, several plants, also here in the Netherlands, they run stable for 4 years. So the job of the operator who is sitting inside is, well, everything is running stable. So that's fine. The problem is when something goes wrong, well, you don't know anymore how the thing is going to react dynamically and what you have to do. So you need a training. It's quite similar to the aviation industry. Eh? A plane goes from A to B, nothing happens. 99.99% of the time, it's all okay. But if something goes wrong, then you wish that your pilot has followed the simulator training in which he has trained how to handle the plane in this situation. And that's the same for operator training, and that's the business case we have. So that's also brownfield. And you see that a lot for all the plants that have advanced process control, that they really want to train their new operators, because it's a problem, especially when the experienced operators are retiring at the moment. I've seen several times in the Netherlands that they actually need to call retired operators because they don't know how to start up the plant anymore. And because, well, the experience has gone and left the company. So you really need some training there. Eh? So that's why we stepped into the operator training business a little bit. And an operator training simulator consists of several elements. And the heart of the operator training simulator is the dynamic process model. And that's what we built. This is actually a screenshot of our modeling software. So what we typically do is we take the P&IDs of our customer and we rebuild that. So this looks exactly like the P&ID they have. And it's typically a set of P&IDs that are all interconnected. The only difference is that it's now dynamic. So you can, with your mouse, you can turn off and on the pumps, and you can open and close valves, etc. And then typically we connect this to a copy of the DCS, so the control system. And we have experience connecting this to Honeywell, to Yokogawa, to Emerson, Delta V, to Schneider Electric, ABB, Siemens, and well, so that means that what you see here is a DCS of one of our customers, and these screens are from Emerson, Delta V of Emerson. And in the real control room, they have 8 screens with Emerson Delta V and these screens on top of them. And this is the simulator room, and it's also Emerson Delta V. So the look and feel for these guys is exactly the same than they would have in the control room. And what you often also see in a control room are these annunciator panels, these hardboard panels with emergency buttons and maintenance overrides, etc. What we typically do is we take a photograph of those and put them on an LCD touchscreen. So if you then push with your finger the button, you see visually the button going up and down. and the lights will start flashing, etc., as in the real plant. But we only need a photograph, so that's it's actually a cheap solution, but it does exactly the same thing. And it has the same typos as in the real plant, since it's a photograph. And the only difference between an actual plant and the simulator is that we now also have an instructor panel. And then the instructor can load scenarios and well, let stuff go wrong and see how these people are reacting to that. So that's very nice. And then, well, we made one extra step, which is also very nice. And because there is one missing element if you have a training simulator, because a normal plant is operated not only in the control room, but also in the field. So you also need field operators who are operating stuff. But since we now have a virtual plant, well, you cannot walk in that. And what you typically see is then that the trainer, he pretends to be the field operator. So when these guys are here, say, well, pump 623 needs to be started, then he waits for a while and then clicks here on the button and the pump starts. Well, but it's not really realistic, of course. And he can start a pump that is 750 meters down the line in just 2 seconds later. So what you see now are these 3D environments. You can put on these virtual glasses. You maybe have seen it. It's really realistic nowadays and impressive. So you can walk virtually to a plant. But that's still a bit of serious gaming. And if you have these virtual glasses on your face for 3 hours because the training takes it long, well, that's a bit much for most people. And you get a bit dizzy after that. We can even do that with photographs, by the way. So then if you click on the button, you zoom in and you can click again, and then the next picture you see is that the valve is opened. But then we thought of something nice, and that's why not use the real plant? Because we're doing brownfield projects, so the plant is there, but the real plant is running steady. So you have to keep your fingers off, but still you can use the location of the real plant for your training. So we come up with a nice solution. Feel free to have a look at our website. We have a very nice short movie, only 2 minutes. It's in Dutch, but it's subtitled, and then you get a real nice impression of what it is. So what we do is near the device that you want to operate, we hang these tags. You can see them, these are NFC tags. And if you go there and you scan them with your phone, and this is an ATEX zone-proof phone, so explosion-safe phone. If you scan it, then a picture pops up of the device. And when you then click the device, then this actually starts or stops the device or opens, close in the simulator. So, but you really have to walk all the way up there. So you have the real noises, you have to wear your protective gear, you have to communicate with the guy in the simulated control room. So it's getting really, really, really real, because you're using the real plant and the real distances. And you can still open or close the wrong valve, of course, and then it still goes wrong. So you can test quite some things. We even made things like this, like a slider. So if you need to open a valve very slowly because it's a steam valve with high pressure, you don't want to open it in one go. So you can do that with a slider, and you can control that. Or if you have a local pressure indicator, you can well, hang a tag there and scan it with the phone and look at what would the pressure be in the situation that I'm training right now. So that's a very nice addition that we made to make our training simulators even more realistic. And on top of that, we actually added even more stuff. So if you scan, you can also pop up questions. So if you're near a pump and you scan the tag there, you get, for example, a question on the pump, and you can get some exams, etc. So well, so it's not only modeling anymore. We're also into the learning, and well, it's a lot of fun to make these things and to see how these are used by our clients. I will skip through it a little bit. Or maybe one more thing. This one is nice. Actually, we did it in a few plants. There are a lot of plants that have a lot of hand valves. And hand valves typically do not have any feedback to the control room. So in the control room, you have no clue if the valves are open or closed. And if you want to wire those valves and put some information to the DCS system, well, it costs you easily $5,000–6,000 per valve. So if you have 1,000 of these valves, it's an investment of 5 million. Well, that's a bit much. So what you could do is you hang these tags near the valve, and when you open or close them, you scan it with your phone. And in the control room, I have, for example, a copy of the P&ID, but now you color all the lines, thick or thin, if they're open or closed. So in one quick view, you can see that they're all here. Tank C has been lined up, and to this B pump. So if the operator calls you and says, well, I'm going to start pump A, you can say, no, let's not do it. And you can prevent problems, for example. So that's a nice addition that we made to our software. And I see we love to show you a demo, eh? That's good.
It will be very nice to see. Very interesting.
Yeah.
And
So if you have some questions in between, then feel free to ask them.
And I see that it's tailor-made for each client, right?
Yes, typically we do that. Yeah.
Okay.
Yeah, maybe it's good to show you this example because I preloaded it. This is because we can make huge models actually. Eh? So the examples I just showed you, they are quite small, but this is, for example, a big plant, and the plant consists of 10 areas. Mm-hmm. And if you then click on one of the areas, you see that it consists of a lot of P&IDs. And if you zoom into the P&ID, then you see, well, this is typically how their P&ID look, but now it's dynamic. So I can now press run, and now the calculation starts. And I can, for example, stop the pump. And the pump is not running, and you will see that the level will surely start rising. Eh? But it's real-time dynamic, so it's the same speed as it would in the real plant. Mm-hmm. But it's all interconnected. So if the pressure starts rising here, the level starts rising, so there is less space available for the gas, so the gas pressure rises, and you will feel that in the rest of the part. You can walk through the whole plant, and it's very it responds very quickly, and you can interact. And this is typically the interface that we give to our trainer. So he has access to all the valves, hand valves, and to all the pumps, etc. And this is then connected to a copy of the control system, and that can be either a real control system, like Honeywell or Emerson or Yokogawa software, or we can actually mimic it ourselves. I can show a quick example of that too in a minute. So then we rebuild the screens, and they look exactly the same, but you don't have to buy an extra license of expensive DCS software. So that's how it works. And maybe this is also a nice point to show you the difference between different kinds of software, because that was one of your questions. Eh? What's the difference between, say, Aspen or Unisim and MOBATEC?
Yes.
So this is our runtime environment. So you can click on this thing, but nothing will happen. But you can also shift to our debugging environment, and then you can get all kinds of data. I won't show it now. And you can even go further and go to our modeling environment. And then you can even, drag and drop and add stuff and completely model everything. So maybe this is a nice one. I will go here. So for example, this is a very non-typical column. So what we do is we build a lot of non-typical plans. So it's not that we have a standard library and drag, drop, and finished. No, we like to do stuff that has not been before done. So there are typically two ways of modeling in the world. Eh? One of them is called flow sheeting. What you do then is you go to your library and you get, I don't know, plate heat exchanger, and you get it, and you just click some stuff, and you add it and you connect it to your screen. That's one way. Another way would be to do equation-based modeling, and in that case, you are typing out all the equations. So flow sheeting, then somebody else has built a model and tested it, tuned it, debugged it. You only have to put some parameters. If you do equation-based modeling, you type out everything yourself, and it's a lot of work, but you can make anything. So, because if you do the flow sheeting part and you don't agree with how it's modeled, well, there's no way to change it. So it's either that or nothing. So, and to give you an impression, I can select this. We can go to our tools and say model generation, show me the code that's behind this. And then you will see here an enormous listing, which is the listing of code that's being computed when I model this. But that's quite hard, because these are thousands of lines. So what we have built is the best of both worlds, so to say. So we can now double click on this one, and then you actually zoom in to the details, and you see how this column is set up internally. And we can zoom in even further. So let's take, for example, the bottom section. And then you see that there is a liquid phase. It's communicating with a gas phase. The red lines are heat, so there's heat loss to metal. And there's a heat loss to the environment. And it's on this level that you can define your equations. And this is actually also our modeling methodology. In our methodology, you can divide any unit operation into systems and connections. And so systems, they represent capacity, they can store mass and energy. And connections, they represent the transfer of mass and energy between the systems. So that's very simple, eh? That's in 2 seconds my 5-year PhD thesis explained. But that's a bit how it works. But the nice thing is, if you now click on this one, for example, you can go to equations, and you see here the equation. For example, it's the heat transfer, it's transfer coefficients times area times difference in temperature, which is a very universal one. And what you see here is, well, this is a very simple solution we took here. And you have the enthalpy balance, which says, well, the heat in minus the heat out. And the nice thing about the program MOBATEC modeler is that it sets up for you automatically the energy and mass balances. So if I make a change here, for example, well, I don't want heat loss, so I just kill it. And then you see here, the balance is like that. And if I press undo, so it's back. Or if I say, well, this is actually wrong, this one needs to come from here. Then all the balance equations are adapted and your model is still valid. And then you can select the part you want to model or compile, and you just press compile and go to simulation, and then code is made for the part that you have selected. And you can test and tune and debug that and improve it. So, and if I wanted to do this little change in the code I just showed, so if I'm equation-based modeling and work like this, well, then it's quite difficult, because then I have to take something out here and maybe add something there. And well, it's very, very error-prone, and debugging is a lot more work in that case. So that's how we do modeling.
Quite impressive. Very, very nice. And you deliver tailor modes for your clients, but you mentioned that it's possible to do the engineer to build their own mode. How they learn how to use the MOBATEC? How is it?
Yeah, we typically have some courses for that. We start out simple, and then we take them hand by hand to make it more complex and more complex. Because simple things are easy also in our tool. Eh? So if I want an extra pump, I just select the pump and I put here a new one, I press copy, and well, I have to reshape some stuff, but then I have my extra pump. And we also have a library actually. So if I close this one, and I open a new library and I say, well, let's insert some objects here. You can make a model very quickly like this. But this is now, well, this is again, like I said, it's close to this flow sheet modeling. Eh? So I can take pump, put it here, and a battery limit, and make some connections. I'll do it continuously. put it here. So we can build from scratch a model quite quickly, you see. And then we have built some easy stuff. So you can click here and you can even go to a pump curve editor and say, well, this is my pump curve and apply it. But then you're actually skipping the whole idea of equation-based modeling. So what you can do also is you can have a look inside. So I can click here and go refine, and then I see how this model is built. I can click here and I can actually see which equations are used. And I can even adapt those equations from a model database.
The tough
and
work,
what we learn.
the tough work is when you need to build equipment that is not in the library, right?
Yes. Then it takes some work, of course. And well, that's what we love to do, of course, to build stuff that's not in the library or to make it different, because sometimes it is in the library, but you don't agree with the equations that are used, or you want to extend it. And you can build it completely from scratch. You can here, well, make another one. So I can go to objects and say, well, let's just insert a system. And another one, and in between it put heat connection. So, and then you are already helped. So if I click here and I go to equations and it says, oh, something is not right, it's improper. So then you zoom into the details and it says, well, this is a heat connection, I need heat. What do you want to do? And I can select it, then it's a constant, and it says, okay, that's good. And then I can give it a value. I don't know, 50 joule per second, or you can even browse here, megawatts, kilowatt. But you can also say, well, that's not smart, the heat is not fixed, so let's not do that. Let's select an equation maybe from our default database. So I can do this one you just saw. So heat is transfer coefficient times area times difference in temperature. But then it said, oh, I have a problem. There's one equation, but now I have 3 unknowns. And then you can choose, do I add more equations? Do I have an equation for the heat transfer coefficient? Or is it, oh, well, let's choose it as a constant. Let's choose this as a constant, and then it says, okay, now I can calculate. And then you automatically come to the next problem because it refers to that's origin and target. So it's the origin of this connection and the target. So it takes the temperature of the origin. So if I click here to the origin, then it says, okay, I need temperature. Do you want to give me a relation that it relate back to enthalpy, or is it fixed? And well, that's the whole way you set up step by step your model. And it's very clear what kind of assumptions you make. And in the end, it generates some code. So if I just choose this as a constant and here choose it as a constant, I can fill in some parameters. And well, and then you can generate your code actually. And it will complain all the way. If I generate the code now, it will say probably a selection is made, okay, then not all variables are initialized. Do you want to search them? And then you click yes, and then you can zoom into all the parts that need your attention. So it really guides you step by step by step to set up your model. And it's real equation-based modeling. And in the end, you can make beautiful applications, of course.
And you can connect that with PLC.
Yes, also, oh, wait, I closed it too far. Sorry. Yes, we can connect with all kinds of external software. And we can also make it look like, let's have a look at this one, the refinery example. So if you look at this one, you can compile this one, and then it looks like this. But you can also, we made for this one, for example, a little control room. So you can even draw up all this in our tool. That looks very nice. You can start and stop, and then it becomes dynamic. We can even make this into a learning module. So distillation, what is that? If you want to learn more about it, next. or what is the reflux ratio, or you could put all information that you want in there. But now I can also start and stop the pump. It's all dynamic, so I can also change valve positions, you see, and then everything is reacting.
Very nice.
Yeah, so we can make quite nice examples in this one. Maybe I think this one is nice actually. Wait, I quickly start over because I need to start something else. This one, because then I can show you where is mobile plant. Yes. When we go to conventions or something, we always show people this one. They can play with our tools ourselves. And that's a nice one because it's a combination of a DCS-like interface. And so I can start production and I can, well, play with faceplates, etc. Open, close. And what we also have is a storage part, and there you see hand valves, but I cannot operate them. So I have to go to the so-called field. And that is what we mimic, where we have a board and we have these tags, and then you bring your phone, and if you scan it with your phone, and then you get a picture. Oh yeah. Mm-hmm. And I can actually press open to the valve, and then it will open in the field. But you don't see it because in the real plant there's also no feedback, so you don't see it open. But there is a feedback with the pump. So this is another tag, and I connected it to the pump. So if I scan this, you see the pump image, you see?
Yes.
So if I now press start, you will see the coloring of this one automatically going on. But press start, whoop, now it's on. See? So I can stop the pump in the control room, but not start it. But I can start it with this one again. So start. So that, well, that's nice. Nice to play with, of course. And we give it as a demo. So we put some images like this, and we put it in the next room. And then somebody is playing the control room operator, and he has to steer the field operator to open and close the correct valves, and then they have to do a nice game, and they have to finish it in 5 minutes before the trucks want to leave. Anyway, if you press load truck, then it loads all the stuff, and you see how much money you made or lost. Now we made bad product, of course, so you lose money, and then it drives away. You see.
Very detailist. Very detailist. The MOBATEC is used for sure for dynamics, but it is also possible to use in SteadyState. Yes.
We have a solver for that. So if you close this one again, all right. I can go to example models. This one is maybe nice. So this is a simple heat exchanger example. But I have to quickly compile it. So if you just press run, then it goes dynamic. You see it, and you can change the valve position. You see dynamic stuff going on. But I can also put our solver into steady state with an adaptive step. And I just press performance run and bam, I have the results. I put this back, and then I press zoop. So you can also solve steady state and get your results immediately. And we made a link to Excel, for example, and then you can control your whole modeling environment via Excel.
Mathieu, one of the challenges for medium to small companies for using process simulation is the fee asked for a year. Sometimes we need to have a contract of 3 to 5 years. And in this way, MOBATEC, not talking about numbers, but talking about feelings. you could say that is more competitive than others, HYSYS or other stuffs? Or
Yeah, way more competitive. I think it's in the order of magnitude of a factor between 5 and 10, actually. That it's cheaper. And we have quite some, we can do a perpetual license, we can do yearly or 3 monthly. And we even have, for people who don't use modeling that much, we have the 100-hour license. So you can model for 100 hours.
Okay. Okay. And if a company
and if you are a student, by the way, then we are even more extremely cheap, and you can just for a few $100 dollars, even less, by the way, you can get your yearly license. It's not completely free, since we are a very small company, and making it completely free would cost us a lot of time, and well, then we would go like this.
No, okay.
But it's a small fee we ask.
And for a company that asks for the MOBATEC, the training is included or it's apart?
No, it's typically apart, because not every company wants it, and some companies do. And we do it quite differently. Some people have some companies have engineers and they want to learn a lot about the modeling. Typically in the beginning we put in quite some hours, and then it becomes less until they actually don't need us anymore, and they just use the software. We have several clients who do it like that, actually.
Okay,
which is also very nice.
Very interesting solution, and very nice solution for sure. And guys, is an alternative for commercial software, because as you can see, it's very intuitive, and of course that the management sees the price, right? We sometimes we know that the process modeling or process simulation in many cases is very useful for doing the chemical engineering tasks and work, but sometimes the price is prohibitive for many companies, and maybe MOBATEC is a alternative, a very good alternative.
Could be. Well, yeah, but it's a little. We are not aiming at the steady state simulation stuff. That for that case, our library is a bit small, I think, and it's maybe also a little bit more work, because dynamic modeling is just more work than steady state modeling. It's just a fact. And well, you have to. But we can also do steady state modeling. But if you are only interested in plant design, for example, then I'm not sure if we are. We probably can do it, but it's not our line of work typically.
Okay,
well, you have to know what you're good at, eh? So that's best. Thanks. I like to work in a niche, which is new, and then become really good at that. That's also the most fun, and it's important to have a lot of fun in your work.
Yes, for sure. And I can see that you love what you do. It's very, very nice when I get in touch with people that loves what they do, because it's not a cliche. We need to work with we like to, because we deliver much more results when we like what we do.
Yes, for sure. And well, all my colleagues so far also love what they're doing, so that's good.
Mathieu, we are going to the end of this recording. Right now it's a recording.
And it's a recording, yeah.
What takes to a person that wants to work with the modeling, not as user, but let's suppose that you open some seats for jobs in your company, what you look for, how the candidate can prepare themselves to work with this kind of industry?
Yeah. I think you really need to enjoy mathematics and equation and programming, and also debugging. Actually, that's quite a part of the work, because sometimes you build your model and it's just not working, and you have to spend many hours to find out that this plus had to be a minus or something like that. And what I like is that people are very proactive, and that they enjoy computer work. And also then they know how to do a bit of out-of-the-box thinking, as we call it here. and also to analyze the problems they're dealing with and find solutions, find and fix problems and bugs. I think it's also very important if you work for MOBATEC that you are able to handle the freedom that I give you, because I give my colleagues a lot of freedom. Sometimes I even don't talk to a certain guy who works for me for a week. And then, well, you can go on holidays in that week, but then your work is not finished, of course. So you have to be able to handle that. It's not for everybody, but the people I work with really love to work this way. I have some people who love to work at night. I have some guys who love to work in the morning. Well, that's all fine as long as you do the job. So that's the kind of persons I'm looking for.
There is any specific programming language, or MOBATEC uses its own?
It uses its own, yes. And I think I quickly showed you a little bit. But you type the equations that you're using. So it's not really, for my employees, it's not really programming. They are modeling. So they are modeling with MOBATEC Modeler. Okay. And I expect the guys who are programming, of course, because I need those guys as well. I don't do everything myself anymore. So.
Mathieu, again, thanks a lot for accepting my invitation. I will open to you say
yes?
final words to the audience, and I hope that we can have good results from this meeting, and we can do business near soon.
Oh yes, that would be nice.
Feel free to
thanks.
Feel free to end this.
Thanks for inviting me. Thanks for me. I had some fun. Also talking about this color blindness. That was nice. I never realized it does impose some limitations, but not much. So you can become an engineer. Well, if you want to be an engineer starting your career, and try to find your passion, I would say, and that works the very best. At the beginning, it's often when you just start out a career, then it's often good to work for a boss sometimes, because some people like to work in big companies. Some thing is possible. Just find your passion and enjoy what you're doing. Also in your free time. I love to have also some free time left, because I really like making music. I play trumpet and trombone and piano, and that's grand. I love my family, of course, and my kids and my girlfriend. That's perfect. So I think that's it. No other wise words.
Great.
Let's see if somebody holds it the whole 1 hour and 10 minutes or something. If somebody actually watches the whole time, we'll see.
If you watch all the video, let us know in the comments, and I hope that I can have you again in the near future, when we can do the live session with internet connection, everything okay.
That would be nice. Okay. And if anybody has questions for me, just feel free to send me a message, LinkedIn, email, whatever. That's no problem.
Okay, Mathieu.
And by the way, if people want to try the software, by the way, just go to the website and fill in to register for our free webinar recording, and you get a 30-day free MOBATEC Modeler license.
Great. I will let the link available in the description of this video. Great.
That's good. Thanks for your time.
See you soon, Mathieu. Bye-bye.
Bye-bye.